Hello students, today we are going to discuss the Maxwell's reciprocal theorem and the strain energy method. Starting with the Maxwell's theorem of reciprocal deflection. Now, Maxwell's theorem of reciprocal deflection has three following versions, that is deflection at A due to unit force at B is equals to deflection at B due to unit force at A. If we apply a unit force at A, then deflection will take place at B, which will be equals to deflection at A due to unit force at B. So delta AB is equals to delta BA. Now the second version will be the slope at A due to unit couple at B is equals to slope at B due to unit couple at A. It means that if we apply a unit couple at A, then slope at B will take place, that is phi BA, which will be equals to slope at A, that is phi AB due to unit couple at B. So phi AB is equals to phi BA. Now the third version will be the slope at A due to unit load at B is equals to deflection at B due to unit couple at A. It means that if we apply a couple at A, that is the unit couple at A, then deflection, that is delta BA, will take place at B, which will be equals to slope at A, that is phi AB due to unit load at B. Okay, so phi AB is equals to delta BA. That is the Maxwell's reciprocal theorem. Now we can move to the strain energy method. Now what is strain energy method? When an elastic member is deformed under the action of an external loading, the member is said to have possessed or stored energy, which is called the strain energy of the member or the resilience of the member. It means that when an elastic member is deformed under the action of an external load, the member is said to store some energy, which is known as strain energy of the member, and it is also known as resilience of the member. Now the strain energy stored by a member so deformed is equals to the amount of work done by the external forces to produce the deformation. It means that the total internal strain energy of the body will be equals to the total amount of work done by the external force to produce the deformation. Now we know that the external work done will be equals to half W into delta, and the total energy stored by the beam is integration 0 to L m square upon 2 EI into dx. Now as per the strain energy method, the total external work done will be equals to the energy stored by the beam. So half W delta will be equals to 0 to L m square upon 2 EI into dx. From here we can determine the deflection of the structure. Okay, so for finding the deflection, we need to equate the external work done with the energy stored by the beam. Okay, now one note is there that the strain energy method can be conveniently used for finding deflection in the structure only under the following condition. The first condition will be the structure is subjected to a single concentrated load. It means that if we make a beam here whose first support is hinge and second support is roller and is subjected to a point load. Now if structure is subjected to a single concentrated point load, then strain energy method can be conveniently used. And second one is the deflection required is at the loaded point and is in the direction of the load. It means that if in the beam deflection is required at C, then we can use the strain energy method because deflection required is at the loaded point and in the direction of the load. That is all about the Maxwell's reciprocal theorem as well as the strain energy method. Thank you, students.